So I was saying before that the arrows you can see this is your sensitivity is on the white axis, and then this is your
Until
false.
there is a
Hello.
problem. Yeah, when you start writing, your voice goes off. Can you please then
Okay.
after that you can speak?
Okay. I did. I've not noticed that. Thank you so much for that. I didn't know.
No problem.
Maybe that's why I've been having the break in. Okay. So let me just write first. Then I'll talk. So I was I was saying that this is a graph here. On the right, on the vertical axis is the TPR, which is also the same thing as the true positive rate on the vertical axis. While on the horizontal axis, you have the false positive rate, which is also the same thing as 1 minus specificity. So they are the same thing. Okay. So I was saying that you need to understand how to interpret this graph. So, how to interpret it is simple. As you are going higher up, you will see that the sensitivity is increasing. When you go up vertically, the sensitivity increases upwards, right? So its range is from 0 to 1 in decimal values. Now, when you go horizontally, the specificity will decrease. It's going to decrease. You know, remember this axis is called 1 minus what? Specificity. So that tells you that it's going to decrease as you are going from the left here to the right. So you can see you have 0 to 1 here, and you also have 0 to 1 here. All right. So if I tell you to give me where the specificity is like, let's say like 0.8. If I tell you where is the specificity 0.8 on this axis, where are you going to give me a plot? So let me just say, for example, you have 0.5 here. So let's say you have these values on this axis now. And then I tell you to give me where the specificity is 70% on this horizontal axis from this 0 to 1, which is the highest. Which number on this axis will be equal to a specificity of 70%? Let me see. Which number on this axis is 70% specificity? Remember, I said that your specificity is going to decrease. That means here is 0, 100%. Then as you are going to the right, it's going to go down to 0. I mean, for specificity itself. So if I tell you to identify the points, which of these numbers here will give me a specificity value of 70%? Which of these numbers here? 0, 0 0.3, 0 0.5, 0 0.7, and 1. Can someone give me an answer? Make a guess.
This is 0.3.
Yes, exactly. It is 0.3 on this axis here, because 0 here, this 0 here represents 100%
Yeah.
specificity, while this 1 here represents 0 specificity, because the formula is what? 1 minus specificity. So if you do 1 minus 0.3, you will, so if you do 1 minus 0.3, that will give you 70%. So the value for specificity that will give us 70% on this axis is what? 0.3. So it's very important that you understand it. So on the vertical axis, what value will give us a sensitivity of 70% on the
Is
vertical axis?
0.7.
Yes, 0.7. So you can see that the vertical axis goes upwards, right? It increases as you go, as you're going upward, while for the horizontal axis, it's going to what? Decrease as you are going towards the right. Okay. So for us to have, so when you now plot the different values for a particular test at different sensitivities, and then you plot those values also against their false positive rate. So you are plotting true positive rates versus false positive rate. So when you plot those values on a graph, you will get something like this. So you will get a curve like this. Okay. Now, if you draw a straight line, from 0 like this. So if I draw a straight line, you see the yellow line there, this yellow line represents any value on this yellow line, So any value that lies on this yellow line represents a point where that test is, that means that the test is of no value. Any value that falls on that straight line tells you that that test is of no value because it cannot differentiate. It is neither sensitive nor specific. That means that what the that you're getting is just a random result. So if you plot different sensitivities against 1 minus specificity, so any value that falls on this line, which is the average, it tells you that test results cannot differentiate well from those that have the disease and those that don't have the disease. So, and at the point of this, at the value along these lines, the value of the curve that will give you this straight line, the ROC value along this straight line is 0.5. The value, the ROC value along this line is what? 0.5. So normally the ROC, the area under the curve, as it gets high, as it gets to 1, 1 is the highest and 0 is the lowest. So as it gets to above 0.5 and then it goes up close to 1, close to 90% and then 100%, which is 1. It tells you that 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 test material that you're using has a good sensitivity and a good specificity. Okay. While an ROC that is 0.5 and below, it cannot differentiate well between positive and between those that have the disease and those that don't have the disease. So an ROC value of 0.5 is useless. It's irrelevant. We want our test results to have a high ROC value like 0.7, 0.8, 0.9. So that tells us that the test can clearly distinguish between those that have the disease, which is what our sensitivity, and also those that don't have the disease, which is what our specificity. Okay. So now we want our ROC curve to be higher up along the left side of this graph. So let me mark the right side. So let's say you have a curve like this. You see? So this is our curve A. Then you have another test result that is like this by the time you plot it. Okay. This is our curve B. And then you have your curve C. So you can see now you are trying to test 3 different test kits for HIV. Okay, and then you use your software or maybe Excel, and then you get different, you do different tests at different times, and then you plot the sensitivity of that test of each test across their various false positive rates. And then you obtain a graph for graph A. Graph A is in red. Then the ROC curve for graph B, that's the blue curve. And then the ROC graph for test C is on the screen. Now, among A and B and C, these are different test kits for HIV. Okay. So, which of the tests do you think is that will give you the most accurate prediction of the disease status of the patient? So between test kit A, B, and C, which one do you think, based on what I have taught you now, on how specificity decreases horizontally as you go from left to right, your false I'm stammering. So as, so as you go from left to right, that means like as you go from here to here, okay? So the specificity decreases, right? Now, as you go from here, 0 to up here, the sensitivity increases, right? So now, among these 3 tests, A, B, and C, which one do you think is the best test kit to use for HIV?
A.
Why?
Because the
Yes.
sensitivity is higher
Yes.
and the specificity is low.
No. Not
Anyway, because I can't know because sensitivity is higher.
yes. So because the sensitivity
You
is
people should
higher,
help
but
me
at the same
see. Oh,
time,
you people should help me. Bikono.
are you not seeing the screen?
I'm not seeing. No, last time too, same thing. Now
Same
again.
The
me,
same
I'm not
thing
seeing anything too.
is
Ah.
it's not true. It's not from my own side, please. You should not accuse me today again. Can you mute
I
your
think we
mic?
should. Let me mute.
I'm not seeing
Okay,
anything.
I will stop sharing and then I'll share it again.
Stop sharing and share it again. And then the people that cannot see too can just go out and come in again.
Yeah. Let me share it again. So I hope everybody can see my screen now. Can you see my screen?
Nothing is up from my
Nothing
side.
is up. It's only your
Nothing is up.
initials, A and U.
Nothing is on the screen now.
Okay. Okay. I get it. Okay, stop sharing. Share. Screen or window. Window. Entire screen. Okay. All right. So can you see my screen now?
Yes, we can see your
Yeah,
mail.
Yes, we can see.
Let me know whether is it from the. You can see my WhatsApp.
We can see something.
We can
Yes.
see everything.
Yes.
Can you see this one? Can you see the graph?
Yes.
Can we see the graph now?
Yes.
Yes, we can. Yeah.
Okay, I think maybe I don't know why. Okay, so I was asking a recap. I said from 0, as you're going horizontally from 0 to 1, the specificity is going to decrease. So that means what? That if you have a value here, at this 0 here is 100% specificity, right? Then as you go down horizontally, this one here will represent our 0% specificity, right? Because this graph is called 1 minus specificity. That's the name of the graph. So that means it tells you that your specificity is going to decrease as you're going horizontally. Now for sensitivity, as you're going upwards, you see that the sensitivity is going to increase. So from 0 to 1. So I said that you are the program manager for a HIV program, and you want to test 3 test kits, A, B, and C, to know the best one to use to do HIV testing in a population. And then the biostatistician, they all plot the different values. They give you a graph like this of sensitivity against false positive rate. So it is now left for you to choose one test among A, B, and C based on what I've told you now. Which one do you think is the best test kit to use in HIV testing? Is it A or B or C, and why? Can someone make attempt? Can you guys hear me? Hello?
yes, Anthony.
Yes, we can hear
They
you.
can hear you.
Mutu
Good.
said
So
that
someone should,
A.
tell me
So
the best test kit to use.
Buddy, I'm so funny.
Yes?
So I actually think it's A, and the reason is because it's the sensitivity, like I said, is higher,
Okay.
and there's the point at which you have the sensitivity,
Yes.
which should be very close to the graph here. I know you can't
Yes.
see me. At that
Yes.
point, if you trace it down, you also see
Yes.
no, but wait though. The
Yeah, it's correct. What you say is correct. Go
the
ahead.
sensitivity at that point is low.
Mhm.
So when you take that,
Sorry,
the
the
specificity at the
specificity.
point, what?
So,
Did you
so
say
let's say like here now. Okay, let's say like here now. This where my
Yes.
So if I trace it down,
Yeah.
is it
So
high
if
or
you
is it
trace
high
it
or low?
down, the specificity you get there, when you take it away from 1, you will be getting a high value, meaning that the specificity is also
High.
high. Yeah.
Correct.
So you
Yes.
want to get as much as possible. You want to get your true
Get
negative being your
closer to
true
the top.
negative and your true positive being your true positive. Yeah.
Good, good. So we will want our curve to hug the left side, the left top side, to be as close as possible to the upper left side. Okay. So the best test is this one, this A here, right? Okay. So you can see that at this point here, let's say if I choose this place here, if I trace it down, you see that this is somewhere around 0.2, which is what? 80% specificity, right? And
Yeah.
then if you mark it here, you see that it's around 0.9, and that is 90% specificity. So we want our test to be as close as possible to the upper left side of this graph. Okay. So if in the essay you are asked to choose, let me clean everything now. So in the essay you're
I have a question. I have a question, please.
okay.
In this this instance you gave, is it that the specificity is low or high? Are we looking at the specificity or the FPR? Because in that case, the FPR is high, but the specificity is low, actually.
In
So
which
what
case,
will give us,
I've already wait.
if
Let
we
me.
are choosing A, that means the FPRO is actually high and the sensitivity is high to give us that A. If we
No,
are saying the sensitivity specificity is low, we are not going to take that A. That's how I understand it. Because we
no.
are doing FPRO as 1 minus specificity.
Yes.
So
Okay.
in that case, we
So
shouldn't say that the specificity is low at that point. Actually, the
wait.
FPRO, that's what is low. That's what is high at that point.
Wait. Voila. Okay. So
I don't know if
wait.
anybody get what I'm saying.
I understand
Wait.
what you're saying.
I don't understand. Wait. Let me write this thing again.
I understand what he's saying.
Good. So here now, our F. Let's say we have 0.2, and we have here is 1. So let's say we have 0.9. So at this point, we have where's my pencil now? Okay, so we have a value here. Can you interpret this? The person that asked is asking me a question. What do you understand? I have a plot here.
Okay. At
Good.
that point, the FPRO is actually I don't know what no that the FPRO there is 0.8, right? Because
No,
the specificity.
no.
Wait, let him finish. Let him finish.
Okay, go ahead.
Okay, the specificity is 0.2, right?
Yes.
From that mark,
No,
specificity
no,
is
no, no, no.
0.2.
No.
Then the FPR, okay.
That's so what I'm saying is that when you're seeing 0.2 here, the 0.2 is telling you that the false positive rate is 0.2. Okay. So it then means that our specificity will be like what? 0.8. So when you do 1 minus 0.8, that will give you what? 0.2. Do you understand now?
Okay, so what you are saying, the figures there on that axis is actually for FPRO, not like
Yes.
specificity. And so if we're interpreting it, we shouldn't mention, we should be relating it to FPRO against
FPR, not
sensitivity,
TPR.
not
Good. So, but now,
specificity.
Not specific.
okay. So now the issue now is when you say FPR, of what clinical use will it be? That's I mean, like if you want to tell it to a layman, which one is of more practical value? Is it the FPR or the specificity? So now you know that our aim here is to get a test that has high specificity and high sensitivity, right?
Okay.
Good. So now, if you are going to interpret it practically, what you're saying is correct. So we can choose to say to talk in terms of FPR, depending on how the exam, depending on how they ask you the question in the exam. So, but what I'm saying is that it makes more sense to talk in terms of sensitivity and specificity than to talk in terms of sensitivity and false positive rates. Though that you can choose anyhow that you want, it's still okay. If you want to say that you want to choose a test with high sensitivity and low false positive rate, you are correct. Okay.
Okay.
Say
Okay.
choose a test with high sensitivity and high specificity, you're also correct. So they're all the same thing. So there is no harm. So I'm trying to explain like this because that's the way it is asked in the exam question. Because the exam is not asking you about false positive rates. The exam is asking you in terms of what specific. So that's why we are interpreting like that. But it's still what you said is okay. I mean, like plain, like mathematics. So your false positive rates will increase from um from 0 to 1. As you're going higher, the false positive rate will increase. So you want to take a test that has a lower false positive rate and a higher sensitivity rate. I hope that's what you are saying, right?
Yeah, sure.
Yeah, so it's okay if that will make you to understand it once. But just know that any value you are getting here along this axis, you have to do one minus that value so that you get your specificity. So in case that's what the question is asking. So I hope it's clear now.
Yeah, noted.
All right. So I was saying that these are the various values for different curves. So I was saying that the curve that hugs this upper left atmosphere is much better. Okay. So you now have what we call area under the curve. Area under the curve. That is area under the ROC curve. Okay, so I was saying that it's called AUC. So I was saying that when you have an AUC of 0.5, it doesn't make sense. It means that
Your mic is going on and off.
yeah, sorry, it's because I'm writing. Sorry. So I was saying that if you have an AUC of 0.5, the test it doesn't make sense. The test and the test that cannot distinguish accurately between positive and negative cases. So any value you are getting is what random. Okay. So by implication, you have that. Let's say this line here, the AUC value is 0.5. Okay, that's where the test doesn't make sense. The test result, the test kit doesn't make sense. Now, as you go higher to the upper left, the next line, the next curve. So let's say this one here. Let's say this one we have an this one we have an AUC.
Is it only me?
So this one we have an AUC of 0.7. This curve here. And so you can see that this red line, the test cannot distinguish, right? As you go up, you see that this one has higher AUC. Okay, so 0.7, and that's good. Now, as you go up again, go higher.
Can't hear again, no? Or is it only me?
I'm not talking now. That's why you're not hearing. So calm down. So as you go higher, you have the next line. The next line is this one. This one has an AUC of 0.8. Okay. Then the next line here, which is this one has an AUC of 0.9. So what does an AUC of 1 look like? If you plot this, you see? So this is an AUC of 1.0. And you know that in real life, you cannot get it in real life because as our specificity we do what? We do what? What's the relationship between sensitivity and specificity? What's the relationship?
You know, I
Hello?
said his voice was breaking now, but it looked as if it was only me. We can't hear you. All those go up, go down. Yeah, I did not hear
I'm hearing
anything.
you. I'm hearing you. You are the only one that is not hearing. The other part not
No,
hearing.
somebody just dropped a chat now that they can't hear you.
Hello?
Your voice was breaking. We were not hearing.
So that I wanted to ask. I was saying that if you have a graph that looks like this, you see that this line is very horizontal, and the value of the AUC at that point is 1.0. What does it mean to you? That's my question. What does an AUC of 1.0 mean?
So this is the
Hello?
highest value, and the specific sensitivity of the test is very high. This is what I understand.
So good. So it means this is a perfect test. It has 100% specificity and 100% sensitivity. So if you do different tests, this is what it will look like. But you know that in real life, you cannot get a test like this in real life. Yeah. So nothing is perfect. In this whole world, you cannot get a perfect scenario. All right. So the only thing that we can do to make sure that the test that we want to choose will be as close as the upper left side. Okay. So we want our ROC curve to be something like this. Okay. Is that clear? Is that clear? Is that clear?
It's not clear
What is not clear again? Ask me
because
the
your voice
question.
is
I
going
can
up
keep on.
and down. Your voice has been
No,
going up and
excuse
down.
me. Excuse me. Hello. You are the only person that have been saying this thing.
I'm
Can you
not the
ask?
only person.
Your
Can you tell
voice
me
People
is
have
what you don't
dropped in the
breaking.
understand?
Your
chat.
voice is actually breaking.
People
Your
have
voice
dropped
is
in the
actually
chat, and you're
Yeah,
saying
breaking.
I'm the
the
only
voice
person.
goes off.
I'm not the
Anthony,
only
when you start
person.
writing, the voice goes
Hello.
off.
Yeah. So you guys ask if you have any particular question. Can you ask it? Because I know I've explained this over and over again. So if you have anything that
It is
you
not
don't understand,
about it is not a matter of if you have any question. The thing is, when you were explaining, your voice was fluctuating. I'm not the only person complaining. If you check the chat, you see that two other
I
people
did.
have complained. So I'm not the only
hello.
one. You see, somebody just said, I don't know why I can't even talk. Somebody is not, I'm not the only one that is saying your voice is going up and down. So when you were explaining, it was off and on. So it's not like I don't understand, but I didn't hear what you explained.
Okay, so my question is, do you have any question from what I've said now? Is there
I
anything that you
didn't
don't
even hear
understand
what
that
you
you want me
said.
to explain again?
I
I
didn't
didn't
even
even
hear
hear
what
it
you said. I didn't
exactly.
get what you said.
I didn't even hear. I didn't hear what you said because it was on and off. I will lose you, then you
I
come
didn't
back.
hear. I didn't
See.
get
A lot of people are.
So what I'm saying is this: which part do you want me to explain again? That's the simple question I'm asking since. What part do
Okay,
you
can
want
you
to
explain
explain
this thing
again?
you just explained? Explain
this
this thing
thing
you
you
just
What is
just
the
explained
thing?
explained. The
again.
graph here.
Because your voice was off and on. We didn't get it. It wasn't
The graph
coherent.
here.
Okay, so I'm thinking that maybe in subsequent meeting, in the next meeting, I'm going to drop a video because it looks like the more I use my pencil, this I'm using now, it interferes with the mic. I think somebody said something like that. When I write on the screen, when I write the screen, it blocks the microphone that I'm using. So that is why I'm going to write first. Then after writing, I will now talk. Okay. So what I was asking is, so I was asking that when you plot your AUC curve and it looks like this, it appears horizontal, and the AUC at this level is 1.0. My question is, what does an AUC of 1.0 mean? That was the last thing I was asking. If your AUC is 1.0 and you have plotted the graph as a straight line at the uppermost part of the graph, what does it mean? I hope you can hear me.
Yes, I can hear you now.
So answer me. What does it mean when your AUC is 1.0? That was where I explained last. That's how the whole thing started, the whole complaint started. So what do you think when you plot your graph and it looks like this, like a horizontal line, straight, and they tell you your AUC is 1.0? What do you think it means?
I think it means the test is highly sensitive and highly specific, and which you said is not seen in nature.
Yes. Okay. So that means our sensitivity is 100%, right? And then our specificity is also what? 100%. So this kind of scenario doesn't exist in real life. Okay. a test cannot be 100% sensitive and at the same time 100% specific. It doesn't happen in real life. So in real life, we only aim that our test should be able to, be as close as possible to the upper left. The upper left is here. So we want our test to be as close as our ROC curve to be as close as possible to the upper left part of the graph. So something like this is okay. Something like this is okay, right? So you have this line here, which is what? Where our AUC is 0.5 on this line. Our AUC is 0.5 on this straight line. So we don't want our curve, our ROC curve to touch this line. Okay, so because when your AUC is 0.5, it means that the test has no distinguishing capability. It cannot distinguish those with a disease from those without a disease. So any result you are getting is random. So that is the meaning of AUC of 0.5. And then I said that we want our AUC to be high, close to 1. So let's say around 0.7, okay? Anything above 0.7 for me is okay. Anything above 0.7, 0.9, it means that the test can distinguish those that have the disease from those that don't have the disease. So this is a recap of what I said before. So any question at this point? Any question at this point?
I think if we take the practical example, the test question.
Sorry, I didn't hear. I didn't hear you. Can you come again?
I say if we take the test question, I think there's a question like this that came out last year. If we can pick that one, it will help us to get.
Oh, I know. That's why I'm explaining this. I'm preparing you guys.
No, yeah, I said for now, what you explain is okay. I think to me, I got what you explained to this point. But what will help me get the point clearer is by taking an example.
Okay. So,
Yeah.
so we'll now go straight to the question. So can someone attempt the question? I'm not gonna answer it. All right. So can someone make an attempt on the question? So this is the question that we have now on the screen. Oh, sorry. Okay, so this is an ROC curve. Okay. So this is an ROC curve.
Yes, Anthony. To me, it seems to be like the curve, the green line. Sorry, the blue line is on 0.8. The sensitivity for this specific line is 0.8.
Okay. Okay. You mean this line?
Yes.
Yes, correct. Anywhere along this straight line. Anywhere along that line is 0.8. Okay. So my question is, given A as a point, then I'll ask you, what is the sensitivity and specificity at point A? So that's the question I'm asking you now. Can you hear me?
I can hear you.
Good.
Just
So
trying to figure it out.
the question I'm asking you now is, at the point A, what is the sensitivity and what is the specificity? A. So point A is the horizontal line. Anywhere along that line. That is what the horizontal line. So where the
So,
horizontal line
Anthony,
joins with the vertical line. So I'm asking, that point is
yeah.
point A.
So vertically, the sensitivity is 90%, whereas horizontally the specificity of the test is 70%.
You mean at point A? Do you mean at this point here? This point here?
At point A, that should be 40%, because we're doing 0.6 minus 1 minus
So
0.6. That should be like
Okay.
40%.
So what is the sensitivity at this point? Sensitivity at this point? Yeah. Where the two lines join together.
That's 40%.
I mean sensitivity, not
Okay,
not
sensitivity.
90%.
That's
90%.
what? What's this?
that's 80%.
Yes,
0.8.
this is 0.8. So it tells me
Yeah.
that the sensitivity at this point is 0.8, which is what 80%. Then if I trace it down, I'm seeing 0.6 here as the false positive rate. So that tells me that the specificity is what 1 minus 0.6. That will be what 0.4. So if a test has a high sensitivity and a low specificity, if a test has a high sensitivity and then also has a low specificity, does it tell you that the test is a good test?
Yes.
If a test has a high sensitivity and a low specificity, is that a good test?
Yes, no.
Is it
Yes, yes.
Why? Oh, yeah, tell me why.
Because the sensitivity is high
Huh?
and the specificity is low.
Okay.
Give back.
All right. All right. Okay. So let me
This is
explain
what we
again.
understand so far.
You see, yeah, exactly. So that's why I'm asking the question. It's not about because the exam may be different. So now look at here. This is where our specificity is here. And I told you that we want our specificity to be what? Closer, right? Closer to this point, to the left.
Yeah,
So,
got the points.
so if you are going from 1 to 0 here,
What is
our
it closer?
specificity, please let me finish,
All
please.
the things
If
I
you are
did
going
in this answer.
if you are going from 1 to 0 here, our specificity
What's his
will
favor, therefore?
increase. So if the
What's favor?
specificity,
Go to WhatsApp. Go to WhatsApp. What's the favor?
hello. So if your specificity is 0.4 at this point here, it is low now. It is not a good test. So like I told you, we want our values to be what? Closer to the upper left. Is that clear? That's the summary. We want our values to be closer to the what? Upper left. So here, this one is upper right. It's not good. Is that clear now? So upper right is not good. Okay. Lower right is not good. whether that will help you to
Okay.
understand.
What we need now, we need a point where the specificity is high and the
Yes,
sensitivity is also high.
yes,
Yes,
and
yes.
So
that
that will
point
be
is
any point towards our left.
yes,
Anything. Okay.
upper
Yeah.
left,
Uh,
upper left is what we
okay.
want.
Okay.
So if we pick here, this is better than
Yes.
this one
Yes.
here.
Yes.
Yeah.
Yes.
So so here, okay, like here now, this test has a very high, about 100%
Sensitive,
sensitivity,
but
but then
specificity is low.
it cannot detect any negative case. So that means everything is positive, positive, positive. So it's not good. Okay. So the relationship between sensitivity and specificity is that as sensitivity increases, your specificity will decrease. So we want to find a balance. So and that balance is around the upper left side of the ROC curve, upper left. So for me, a very good test would be maybe something around maybe here or here, so that you can see that I do 1 minus 0.4, I'll have
Anthony,
like
sorry,
have like
there
2%.
are 100 of cursors on the screen.
I mean,
Can
like
you
a
please?
million of them.
Yeah.
What?
Can you please? There are 100 of cursors on the screen.
Oh, sorry. Okay, can you see? Is it clear now?
It's better
Yeah.
now,
So
yeah.
we get the
Oh,
point. Yeah. Can you identify
oh,
again?
okay. So I was saying that I want my ROC to be at the upper left. That is around this side here. Upper left. Okay, so that's the key. We want our test results to be around the upper left. The ROC curve should be as close to the upper left as possible. Is that clear? Is that clear?
Yeah, that's good.
All right. So who will answer the first question?
Where is the
So
question?
the question is this one. So the ROC curve is an assessment of FEV lung function parameter. Okay. As a prognosis for pneumococcus. So the disease is called pneumococcus. So the first question is to draw 3 circles on the curve. It has started though.
We've lost you.
So
We've lost you, Anthony. We can't hear you.
read the screen. I'm waiting for you to answer the question. You have your question on the screen. Can someone make an attempt? That's what I'm.
Okay, so they said draw 3 circles on the curve to identify good threshold values. If 1, sensitivity is considered to be of high importance, specificity is considered to be of moderate importance. Please, can you scroll back up so that we can see the curve? So for the first one, sensitivity is of high importance and specificity is of moderate importance. So that would be
That point we've been discussing, like in between
this
in between 4 and
straight
6.
line that crosses 0.8 and 0. This straight line that crosses 0.8 on sensitivity and 0.4 on
Exactly.
specificity. For me,
Specificity.
that would be the for number 1. They said sensitivity is of high importance. So for me, it will be this straight line that crosses 0.8 on sensitivity and 0.4 on
The screen has disappeared though.
chai.
I mean, hello.
Yeah. No screen, Anthony.
No screen, no
Hello.
screen.
Can
Yeah,
you
we
see
can
my
hear you.
screen?
We can
Yeah,
hear
we can
you.
see it. We can see it now.
All
We
right.
can see it.
So as I said that you should just give me
So
the
I can't
values,
see
then
it
we'll
yet,
plot it.
so
Uh-oh.
I can't see.
Excuse me.
After call about what is it?
Who is giving the call? I don't know. Hello, can you see my screen?
Yes.
Yes, we
Yes,
see screen now.
yes,
Can you see inbox?
Yes.
yes.
I don't know. Okay, so can you see the graph?
Yes,
Can you see the graph?
yes.
Okay, so go ahead and tell me where to plot now.
So for the first one, it will be this middle.
Just guide me. I'm moving my cursor. Where do you want me to plot?
Come down a bit.
Down?
Yeah. No. Up. This straight
Okay.
line. This long straight line. Yes. The middle part. Or yeah. Maybe that
This one?
place.
Okay.
Wait, I want
Here.
to ask, does it have to be an edge? Maybe it can be any part of the curve.
Yes, any part along the curve.
Yeah, so
Any
this
part,
line, this 0.4 line on specificity, this middle part, yes, around that place,
Okay.
yes.
Okay, here is okay by you.
Yes,
Okay.
but there are plenty course, so I hope you know where I'm talking. Yes, that line, this line.
The cursor is the plus. It's just plus. That's
There are
the
plenty
cursor.
pluses.
I don't know. Maybe it's network. It's not from
Yes,
my own.
exactly, that point.
Okay. I've
Yes,
removed it. Are you
yes.
seen any pluses again?
I'm seeing only one. Yes, yes.
Okay. All right. So what
That's
is the
for the
value
first one.
of your specific your sensitivity at that point?
My sensitivity at that point would be about 0.8 something.
Okay. Then your specificity is what?
Specificity at that point would be
0.6,
0.
that's 60%.
Correct.
Yeah,
Correct.
60%.
Correct. All right. So let's go to the next question. Question number B.
Says specificity is considered to be of high importance, and
Yes.
sensitivity is considered to be of moderate importance. Yeah, let's go up.
Yes. Okay. Yes.
Now, specificity is of high importance, and
Yes.
the other one is of moderate importance. For me, it will be at this point where sensitivity
That's
is about
0.2, trace it up.
0.6 and
Yeah.
specificity is about 0.2. Yes, somewhere
Yes,
around there.
Okay. 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 That's good. That's good. Then the last question.
Both are considered to be of equal importance. All right.
Good. Wahala. All right. Yeah.
Nathaniel, over to you.
Eh, in that case now,
In that case, I think it will be at this point where sensitivity is about 0.7 and
Correct.
specificity will be about 0.3.
Correct. Are you seeing that? It's correct. So that means both the sensitivity and resistor are around 60%, right?
Yes, but sensitivity will be about 0.7 and then specificity will be about 0.3. This middle.
0.7. No, wait.
0.7 for sensitivity, yeah.
Uh-huh.
And then 0.3 for specificity. That's
No,
70%.
that's 0.3. That
0.3
0.3 is
for false
0.7.
positive rate, which is equal to
No, I didn't get you.
70%.
I said is not 0.3 for specificity. It is 0.3 for false positive
Yeah,
rate.
yeah.
Okay? Which is now equal to 70%.
70%.
Yes,
Yeah.
yes. Okay, yes. Sorry.
All right. So with these few points of mine, I've been able to convince you and not confuse you that ROC curve is simple. All right. Okay. So number B. Can someone attempt it?
How would you rate a diagnostic test with an area under the ROC curve as 0.5? It's random.
It's
You
useless now.
can't. It's random. You can't
Okay.
actually tell if it's
Okay.
good
So
or not.
can someone browse AUR of 0.5 on Google and tell us what they get? AUR of 0.5. What does it mean?
Well, I think you mentioned it earlier now that
I know.
anything
Just
around
browse.
there.
Just browse it. Just browse it on internet. Let's see what we can get. What does AUR of 0.5 mean?
It means it ranks, can you hear me? It means it ranks a random positive example higher than a random negative example 50% of the time. As such, the corresponding classification model is basically worthless, as its predictive ability is no better than random guessing.
All right. Okay. I hope it's clear. Next question.
So it's random and it's worthless. Not right on them.
Next
It also
question.
says there's a bug in your data.
Sorry?
Next question.
Google it up, says that there is a bug in your data.
Next question is
Sorry.
question number C.
Where this thing? I can't find my See, name one detrimental outcome that may arise from the use of screening tests with low sensitivity. So the detrimental outcome that can arise from the use of screening test with low sensitivity. Low sensitivity means false positive, yeah? Abby? Now, so when you give somebody a test and it's false positive, you increase trauma now, and
It can lead to litigation, as in court case. Now the person can sue you when the person finds out that
yeah. So because you lead to trauma, you won't keep person, person will go and be having BP problem.
someone that doesn't have HIV now,
And then you can't tell the person has HIV.
I
Wahala.
go sue you.
Hello.
Yeah.
I can hear you, but it's faint.
Now we've lost you.
Anthony, we can't hear you. Yeah.
Motoraya, I found you.
Me, I can't hear him again.
He's lost. We'll find him very soon.
Hello.
It's very faint.
Faint.
Hello.
Hi.
It's coming up now.
You're lost again.
Oh, we found.
What's all this now? What's the meaning of sensitivity?
Sensitivity is true positive.
Can you guys use Google and Google the meaning of sensitivity, please?
True positive. Again.
Use Google and Google the meaning of sensitivity. What's the meaning of sensitivity of the screening test?
The ability of a test to correctly identify patients with disease.
What's the meaning of specificity?
The ability of a test to correctly identify people without the disease.
So answer the question number C. What's the meaning of that the test has a low sensitivity?
Low ability to test correctly.
Good. So what do you think will happen when a test has a low sensitivity?
Not good now. The test not good.
It's not
it's not
the test
reliable.
is not reliable.
I mean, like with the test, sensitivity is the ability to identify when someone has disease, right?
Yes.
Yeah.
So if that ability to identify a positive case is low, what will be the commonest result of the test? Like,
It always
let's
be
say
negative.
Negative.
So
We
that
have
means
most
you
of the results as negative.
Good. So that means you have high levels of false negative, right?
That one bad.
Okay. So someone will have HIV and you do test and the person will say he doesn't have HIV, right?
Hey.
So what is the outcome that will what will likely happen if you have that kind of test that doesn't identify a positive case?
So the person will go on thinking he doesn't have,
It's
and then
fine,
the disease
yeah.
aggravates. It becomes
difficult
like
to treat.
the person can go without being treated, thinking everything is okay.
Yeah. Maybe in case of cancer, like early detection, you can be able to solve the issue.
Okay.
But in this case now, because it was not detected, yeah.
Good. So let's say someone has
Anthony, in case of COVID-19.
So what will happen when you have low sensitivity in COVID-19 screening?
Person will die, ne?
Person will die.
Apart from the
person will infect, it will infect a whole lot of persons before we detect it.
Good. Apart from infection, what else will happen? What will the infection cause?
Will spread the disease more if they get a false positive or negative.
resulting to when the person spreads the disease, what will happen?
More
More deaths.
infectious.
And then what will
More
happen?
infection.
Then what will happen?
Economic loss.
Yes. But what is the term when the infection increases?
Prevalence.
The things that we have been solving all this while, what is the time when the number of infection increases?
The prevalence
Wait,
will
don't
be high
tell
now.
us. Wait, just wait. Let everybody should wear their thinking cap. Although I carry cap for this.
When the infection increases beyond normal, what is it called?
It's endemic or I don't know what you want.
Pandemic, endemic.
Pandemic.
No.
It will lead to an epidemic, right?
Epidemic. Yeah.
The pandemic.
Whether
Epidemic.
pandemic or epidemic, they are
It's supposed
from
to be
epidemic.
pandemic.
Yeah, it's
Yeah,
supposed
from
to be pandemic. Now
to now
epidemic is
to
like
now go to
a stable
pandemic.
condition. Yeah.
Mm.
All right. So question number D. Name two detrimental outcomes of low. Oh, I think they made mistake here. This should be low specificity, right? Because these and these are the same. So let me change this one to low specificity. So tell me what will happen when a test has a low specificity. What will happen?
Opposites.
Tell us now.
What's the opposite?
What's the meaning of? What's the meaning of? What's the meaning of?
We've lost you. I can hear you again.
What's the meaning of specificity?
What's the meaning of sensitivity? Is that what you're asking?
Answer
Specific.
number D.
Specificity is the ability of a test to correctly identify people without the disease.
Okay. So what will be the test result look like when a test has low specificity?
Or is it false positive? No, false negative.
That's false negative now.
Now, but this thing say person is supposed to reason himself. Well. Question.
That's false negative.
False negative.
The person has the disease, but the test failed to
Okay.
diagnose it.
Wait. Let me change the question so that we understand it. Fine. I'm changing it to fine.
Your voice is
Okay.
lost.
Good. Answer question number C. I'm changing it to high. So this is high. And this is also high. So what does high sensitivity mean?
Test is good to go.
What does high sensitivity mean?
That means the test can accurately detect those persons that have the disease.
Positive outcome.
Yeah, positive. Those persons that have the disease, the test can easily identify them, or has the capacity to identify more of those persons.
Okay. So, but what of those that don't have the disease? When the test is highly sensitive, what could happen? What is bad? When it has high sensitivity, but then it has a low specificity, what will happen?
We didn't get that. I didn't
When
get
when a test has a high sensitivity, that means it can detect positivity.
your voice is lost.
No. When a test has high, what does it mean?
High sensitivity.
Yes.
High sensitivity means it can actually tell us correctly if people have the disease.
Okay. What does this one mean? High specificity. What does it mean?
It can identify people that don't have the disease correctly.
Okay, so step down your now. What is what is the disadvantage of a test that has just high sensitivity only?
I didn't get that. What is the
What,
disadvantage of
what
it?
is a test that has high sensitivity?
Can that be? Name one detrimental outcome that may arise from the use of a screening test with high sensitivity.
Yes.
I thought we had answered this question.
No, I said high. It's now high. No, it's not that. Tell me.
Before was low, now it's high.
Yes. So if a test has only high sensitivity, what would it mean? The disadvantage of a test that has just only high sensitivity is only to understand.
Sensitivity is high.
Yes. Is there any disadvantage of that?
I think I
Only.
don't know, but I may be wrong, but if the sensitivity is high, all well and good now. That means that's a but wait to that but there's some diseases that there's some diseases that you don't want to have high sensitivity.
Good. Now you're thinking. So if I do a HIV test and I'm loving everybody has HIV, everybody has
Okay, so for when the sensitivity is high, actually, if the disease is a terminal disease, wahala go dey.
Okay. So let me what I'm saying is sensitivity is right. So if you have a test that is only positive,
Your voice is going on and off, really.
whether disease or not positive, what will it result to?
I didn't
You
get
didn't
the
get the
question.
part. Your voice is lost again.
Completely.
I think if the test result is saying positive for all the tests, what will it result to?
If they are getting positive for all the tests,
Yes.
there'll be false positive now.
There's no
That's
false
what you said.
positive.
That's not what we said that it will lead to it. It's false positive. It will be false
Good.
positive.
Good. So you can see that.
Uh-oh.
Don't worry, I'm here. Don't worry.
Network today is something else.
This way.
Okay. I don't want to talk. Let me not confuse you guys. No need. So basically, when it is right.
See, Grammarly. Grammarly say make people stop.
So when the test is high, it can detect a negative when they are present. Can you write it down? When the test is highly sensitive, it can detect positive cases when they are available.
Can you please type what you're saying? Because we can't hear you really. Is it possible? Please. Please, just type it, please.
Hope it's clear.
Yeah.
So what will happen when you have a test kit that has low sensitivity? That's my question.
You won't be able to detect positive cases.
Question number C. Answer question number C.
Name one detrimental outcome that may arise from the use of screening tests with less sensitivity.
You won't be able to detect positive cases properly now.
Correct. It's correct. Now, answer the next question. Answer this one.
Ability to detect negative cases will be low, so it will be giving people positive cases instead of negative cases.
Right. Motu.
What's the answer to number two?
Maybe that.
What's the answer to number three?
They said 2 detrimental outcomes that may arise from the use of screening tests with low specificity. This specificity shall know it won't come on my teeth.
Go special class, man.
What's the answer, please?
So it won't be able to so wait, let me not to reason this thing well before you go where rubbish. It won't be able to detect
It won't be able to detect
negative cases.
when they are present.
Yeah, so it will be giving people positive.
Okay. So what
But there may be a terminology. What's the epidemiological terminology to explain this?
really?
What?
High false positive rate.
Didn't hear that.
Can you write it?
That's the answer.
They said 2. What's the second one?
I don't know.
You don't know.
Motu, what's happening?
I'm giving you the so
Okay, we'll find out. Let me go.
okay. I'm giving you one. I'm giving you one answer for this one.
It's not cost effective now because it can lead to high cost because the person will have to go visiting other testing.
Yeah, person would have to
places.
try and do a more, which may cost more, yeah?
Yeah, more tests
And
to actually see if he or she is positive or not. So there's cost implication.
Wait, though.
Can you see my screen? High false negative. See this one. A test is specific when it can detect what? Negative cases, right? When they are available. So if it has low specificity, that means it can no longer detect negative cases, right? So you will have high level of false negative. High level of false negative.
Which is worse.
Which is worse. Yeah.
We are not disputing that. That's very correct. But
The
since they said
second
two, we are just thinking of what will likely be the second reason.
one, do.
About now, let me continue with other parts. Oh, we have reached the
Is
end
there
of this question.
something that
Okay, we have reached the end of the exam section. Let me revise the question. The last time. How many of you were not here in the last question?
We
Hello?
can't even hear you.
someone
Okay.
can see the screen? No,
Okay, so
someone can't see the screen.
it's not my.
Oh, okay.
All right.
Can you log out and log in, Mr. Tony?
I'm trying to see whether I can log out. I don't know why this network is just unstable. Click here to join the link. I don't know why.
Are we still in this class? Because me, I can't hear anything again. No.
I can
Same
only
here. Same here.
hear you. But please take over the class.
Nah, take over, Sha. When Nathaniel did there, Nathaniel na prof.
Nathaniel,
I don't understand what you guys are saying. In fact, I'm
Oh,
drinking
I
beer.
didn't
I'm,
say that
I'm
question.
drinking
Can you
cold.
please?
I'm drinking cold beer.
beer.
The weather is a bit warm today. Let me drink beer.
No wonder you're giving us correct answers.
Okay, I'm back.
Welcome
So
back.
it's almost 7:30 by my time. 1 hour. I'm going to stop the record now.